So in this video, I'm going to demonstrate a couple of ways that you can geocode point location. So for this specific step, what you need to do is use a table dataset, so tabular dataset, so the quick trip data, which initially we read as a CSV file. As you can see, it's a CSV file, and we read it as a CSV file, and then we are going to use that to create a point file, and then we are going to create that 0.5 mile buffer to check, whether adding the quick trip as a kind of grocery store will increase food accessibility. To start out with, if you look at the table itself, you can see that there is store number, address, city, state, zip. So I downloaded this data from the quick trip website, and they have latitude and longitude. To be fair, using latitude longitude is probably the most easiest and accurate way to go forward. Okay, so here you see that just by creating a new variable quick underscore shape, SHB, and I'm calling the GeoPandas function, where it's using the CSV file and using the geodata frame function to convert the CSV file based on that lat long column here, and it's using the store CRS, which, if you remember, is WGS84, because this is a WGS84 format, and I can plot it. So you can see it's for the whole region of Wisconsin, Minnesota, Iowa, and so on and so forth. And if you look at the shape here, it's a pretty big data set, so 850 data set, right? And we can kind of clip it to lacrosse and go forward. But here is the thing. It's great that this data set has a latitude longitude, but let's say for your final project you're working with a data set which only has addresses, or you created a data set which only has addresses, no lat long. How will you get lat long, right? So that's why we are going to use a package here. In the beginning, you have imported Nominatim, and what it is, it's like geocoding addresses. Very similar to what you guys may have done in ArcGIS Pro. So it will take the addresses, and Nominatim is based on OpenStreetMap geocoded address. So OpenStreetMap, if you know, we have OpenStreetMap, this open source mapping platform, where you can find, basically it's like a wiki map. So you have all the information, and you can add information, download information like that. So it's using this as a back end to gather addresses. So this package, what it's doing is basically comparing these addresses with the back end of these OpenStreet addresses. But the glitch of working with that data, with that package, is that it takes a lot of time to work with that data set. Right, so we need to filter it down. So for example, we saw that there are 850 data points right now. The first thing I did here is that I created just the subset for the quick trip, and this is going back to the CSV. So forget about the lat long conversion that I just did. This is as if, let's say we are starting new and we do not have the lat long information. This is just the quick trip CSV with the address data set. So I used the state column, and I said I just want those state with Wisconsin. Okay, so state equals Wisconsin, and I have, now you will see if I print the shape, print Wisconsin shape, you will see that I have now 504. Not, quite a lot as well. So we just got rid of 300 something data set. So now I'm going to look at the cities, because again, we are looking at La Crosse on Alaska, probably West Salem, La Crescent, not even La Crescent, West Salem, let's say, these type of neighboring towns and cities in the region. So right now so that's why I'm calling the city column here and calling the .unique function to tell me what cities are listed here. So you can see ton of cities are listed. And then I'm creating a subset again here, quick trip within square bracket, quick trip again within the city column is in. That means within the city column, look for only those cities that says Holman, La Crosse, Onalaska, West Salem. So it relates to the same formatting as it's provided here. So you can see Onalaska in here, and then Holman on the top, West Salem here. So it's going to then pick and choose these cities, and then we'll come up with, oops, I have to run this, and then come up with number only 27 data points. So now we have only 27 addresses to geocode. Now you see that I have addresses as separate, right? Address, that's the street, the number and the street name, the city, state, and zip. What happens is that in Nominatim, the package that we're going to use, it needs everything in one row, like in one cell. So we are creating a new column called whole address, and that whole address is basically a combination of address, comma, city, comma, state. I don't even need the zip, and I'm going to store it as a string. Okay, so now I'm going to run this, and you can see the address is here as usual, and this is the whole address. Everything as a one cell, in one cell. Now I'm going to reset the index 1 because I subsetted multiple times, so these numberings are kind of all mixed up. And what Nominatim does is that it goes by index number, because we have to run a for loop to go through each address. So we need to reset the address so that it's, you know, kind of reads from 1 through whatever number. So we'll reset the address, and let's see what the reset address index, looks like. So now we have 0, 1, 2, 3, 4, so on and so forth. The whole data set is now printed, right? So now I'm going to actually this is a function to ignore the warnings, because it keeps on generating warning. So things like it cannot geocode or something like that. Okay, so let me explain the code first, and then I'm going to talk about the warnings. So here you see that these are standard, like importing packages. Then I'm going to use a geolocator. I'm creating a new variable called geolocator and calling this package Nominatim. User agent, just give your own name or anything, like, you know, class name. This is basically just a starting point. And then assign and create a new variable and assign the column where your whole addresses are stored. Then you have to create new columns here where you're going to store your new lat-long information, because remember, the goal here is to gather lat-long from these OpenStreetMap. We are assuming we don't have this lat-long information, so-called hypothetical data set, right? So now we are creating this for loop where we are going through the range of this quick trip Wisconsin data set. So it's going to take the whole range of 27 data addresses, and it's going to look for location in this whole address. So I would be looking for each address. Timeout means it's going to check for like 10 seconds for each address in the OpenStreetMap. And if the address is found here, they're going to store the lat-long in this lat-long in the column in this latitude and longitude format. If it's not found, it's going to print this error message that this address is not found. Okay, and then finally, once it's done, it's going to print off the data set that it created. So I'm not going to run it because it's going to take some time. It takes like at least 10 to 15 minutes to run it, even with just 27 addresses. Okay, so yes, it is time consuming, and that's why we try to avoid it, but it's a good way to geocode addresses, and it's probably the only free method to geocode addresses in Python. You can use Google Maps and other services, but those are paid services. This is the only free service that is available. Right, so here you can see the output message. Here you have the error messages, and that's because these addresses it couldn't geocode. So the deal is that if you search for this address here, and let's copy this address, let's copy the first one, okay? And let's search it in OpenStreetMap, because it's searching through OpenStreetMap, so we have to cross-check with OpenStreetMap. We cannot cross-check through Google because Google is a commercial software. It is more advanced and has a lot of functionalities behind the scene going on that we cannot see. So if you see that there is no result, right? And that's the reason why it is throwing this error, because it's not in the database. So what if I move this number 870 or delete this 870 and search for it? It's still not found. What if I just search like this? It's still not found. So now let's see what's going on. Is it something, you know, not real, or what is it? So if you find this, it is real. So we do have a quick trip, which is 870 alt fields here, but turns out it's not within the OpenStreet Geo database. Okay, and also and so once you see this happening, then you can see that there are few among the 27. There are almost 6 of them. You can see that there are no quick trips available in this database. So this one was the another one. Here you will see that the other one, support center, is not available as well. So first of all, you see that we are biased by this OpenStreet map database, right? So one thing is that. Second thing, if we are comparing some of the original lat long versus the geocoded lat long, let's say the one in the Holman here, the lat longs are different, right? Because let's say if I copy this, okay, copy, and let's open this in Google Maps, and you see it kind of lands in the middle of nowhere in here, right? This is Google Maps and this is the quick trip, and whereas if we use this one and place this one here, it kind of locates in the right spot. Advantage of using existing latitude and longitude is that we don't know how accurate that is, but it's fast, right? And here the geocoded addresses that we are using, we know that this is highly accurate, but then again, because we are using the OpenStreetMap free service to geocoded, not all the data set is available there, like this one, which there is no lat long. Right, so and so that's what the goal of running both ways is for you guys to learn that yes, I can use latitude and longitude from a CSV file to create point in Python, and also I can use addresses to create point in Python as well. And therefore, what are the benefits and what are the disadvantages of each of the methods?